With Vericut's new additive module, you can now simulate both additive and traditional machining capabilities used in any order on hybrid CNC machines. Simulating both operations can identify potential problems that can occur when integrating additive methods. The user can access detailed history stored with Vericut's unique droplet technology, which saves programmers time by quickly identifying the source of the errors, in most cases using a single mouse click. This additive capability checks accurate laser cladding and material disposition, detects collision between the machine and the additive part, and finds errors, voids, and misplaced material. For the highest accuracy, Vericut simulates the post-processed NC code that will be used to drive the CNC machine and ensures proper usage of additive manufacturing functions and laser parameters. Users can virtually experiment with combining additive and metal removal processes to determine optimal, safe hybrid manufacturing methods. Additive manufacturing applications create new possibilities for manufacturers, and adding this technology to Vericut provides unique solutions that address the needs of our customers in this rapidly expanding market. And that's it. For more information on Vericut's new additive module, see the Vericut help. Vericut's Force optimizes NC programs by analyzing cutting conditions such as force, chip thickness, and feed rate. In 8.1, Force can display charts in real time, revealing cutting conditions and forces as they are encountered by the cutting tools. This feature allows the NC programmer to identify undesirable cutting conditions such as excessive force, chip loads, tool deflection, or material removal rates represented as spikes in the charts. Force charts are now dynamically linked with Vericut's NC Program Review, making it easier to review problem cutting conditions. With one click on the chart, the user is taken to the location in the NC program and shown the actual cut in the graphics window. By optimizing toolpath feed rates, Force reduces production time, prolongs tool life, and produces a higher quality finished product. And that's it. For more information on Force, see the Vericut help. Vericut 8.1 has enhanced support for grinding and dressing operations. Users can now simulate dressing. This is where a dressing tool is applied to a grinding wheel to dress the grinding surface or to change the grinding wheel's cutting shape. With these enhancements, Vericut now simulates continuous dressing while the grinder is engaged with the part. These types of operations are supported regardless of whether the dresser is spinning or not spinning. And that's it. For more information on Vericut's new grinding and dressing capabilities, see the Vericut help. Vericut's new section dialog makes it easier and faster to see inside the part during simulation. This allows the user to check proper fit and identify interferences between the workpiece and the machine components. Sectioning abilities in 8.1 extend to the machine view, which help with complicated machine where visibility is challenged. Simulation can be stopped, rewound, sectioned, and zoomed to achieve obstructed viewing needed to pinpoint errors highlighted during the simulation. And that's it. For more information on Vericut's sectioning abilities, see the Vericut help. X-caliper is used to measure the Vericut model. In 8.1, measurements are shown on the part, can be rotated with the part, zoomed, or dragged to a different location. Multiple dimensions can be displayed to quickly document key measurements with on-part dimensions, and setup dimensions designed for inspection aids. The dimension images can be easily referenced in the Vericut reports. And that's it. For more information on Vericut's X-caliper dimensions, see the Vericut help. In 8.1, revisions to the report template make creating a custom report easier. Now the user can add report content directly to the report editor by adding text, tables, and images. The new template creator gives the user a "what you see is what you get" display that shows exactly what the report will look like before it is created. The page can be set up just like a typical word processing type application. Text and tables can be typed directly on the page, and formatting can be adjusted directly on the text. Tables can be modified at any time to add columns and rows along with merging desired cells. Images can also be added and dynamically modified to fit the user's needs. In addition, loop areas that show repeating content are now graphically shown on the document's display. And that's it. For more information on Vericut's report template, see the Vericut help. The features on the Configure G-Code Offsets menu enable you to add work offset tables. In 8.1, this area has been completely redesigned to simplify the setting of the work offset tables. Now, with the From location set automatically, the user only needs to select a location for the new work offset. New logic has been added to Vericut, which will verify the syntax of the input text to ensure that it is supported by the active control. Location markers have been introduced to the graphic area in order to illustrate the location of the highlighted work offset. And now, all available offset tables have been consolidated into one location under a single ribbon pick. And that's it. For more information on Vericut's new G-Code offset tables, see the Vericut help.
This video will provide a brief overview showing how simple it is to run a Vericut session and use the Teamcenter interface to retrieve 3D cutting tools from Teamcenter. Here we have an example of a typical 3D cutting tool assembly that resides in Teamcenter. The advantage of using the Teamcenter interface is it connects directly to the user's Teamcenter PLM database to reference files, avoiding the need to create an external, uncontrolled copy of the model on a local network drive. We are now ready to launch the Teamcenter interface from Tool Manager in Vericut. Here we have the Teamcenter interface. The fields allow for searching of an NX CAM project or individual tool assemblies. In this search, we find an NX CAM project, and the interface lists all the cutting tools used in that project. To load those tools into Tool Manager, we simply select Import All, and all 3D cutting tools for the job will be imported at once. The Teamcenter interface connects Teamcenter PLM and Vericut to help you reuse existing 3D cutting tools for your simulation. It allows the user to reference tooling stored in Teamcenter without the need to create external uncontrolled copies of 3D models, which creates a much more efficient process. Vericut runs independently from Teamcenter and NX, so you can continue working in that software while simulating your NC programs. Here we have the Tool Manager session with the 3D tool assemblies imported from Teamcenter and ready to simulate the CNC machine. And that's it. For more information on the Teamcenter interface, or to request a step-by-step training session on the Teamcenter interface, please contact our technical support staff.